Hello, everyone, and welcome back. This week, we will continue the Applied Medical Statistics playlist, which targets all practicing physicians, junior medical practitioners, medical students, and board exam takers. As I said in my previous presentation, this playlist will not provide a comprehensive statistic presentation. It is rather a concise refresher for the practical application of statistical principles and concepts in medical care and clinical research. So let's start. Today, I will talk about risk and risk measures. And risk means the probability of an event or outcome occurring in relation to certain exposure. And today, we'll talk about two risks, which are the relative risk and the attributable risk. In my next presentation, I will continue on the risk measures and will expand more. So let's talk about the relative risk, which is usually used in cohort studies. The relative risk is a statistical measure that compares the risk of an event occurring in an exposed group to the risk of the same event occurring in an unexposed group, which means we make a comparison between the exposed and non-exposed, and we calculate the probability of occurrence of the outcome in the exposed group and compare it to the probability of the outcome occurring in the non-exposed group. And that's literally the relative risk. So as I said, we usually use this in cohort studies because if you think about it, in cohort studies, we start with exposed and non-exposed group and follow them over a period of time to see who will develop the outcome of interest. So since we start with exposed and non-exposed, so we can calculate the risk for each group and then relatively compare the two groups. And when we say relative, that means relation. The word relative means the relation between two groups. So that might help you remember what is basically the relative risk. So two separate risks, and we measure the relation between them to just understand how much the exposure is associated with the outcome. It's not causality relation, it is just association. It's not about causality. It's about determining the association between the risk factor that we are studying and the outcome of interest. That should be clear in our understanding. So, for example, if we have exposure to one of the risks known to lead to certain disease, we will do a cohort study to witness the impact of that exposure on the individuals who have that exposure and to measure how many of those individuals develop the outcome of interest. And the same for the non-exposed group. So we can make this calculation and say, okay, the relative risk is so and so. I hope that's clear enough. Okay, so the relative risk, as we said, is the risk of developing disease in the exposed group divided by the risk in the unexposed group. And here we have the 2 by 2 table. As you remember, the exposure is on the top row and the non-exposure in the bottom row. I highlighted the exposed group by yellow and non-exposed by blue. So when we calculate the relative risk, that means we calculate the risk among the exposure, which is literally A, which is the cell that determine the people who are exposed and they got the disease. We divide that by A plus B, which is the total of the exposed population. So among the exposure, we calculate the risk by dividing the number of the exposed and got the disease by the number of all exposed population, regardless they got the disease or did not. So in statistical term, it will be A divided by A plus B. This is the first half of the calculation. The second half is to calculate the risk in non-exposed, highlighted in blue, and that is C divided by C plus D. And that represent the non-exposed population but got the disease and divide them by the total of non-exposed population, which is C plus D. So to understand it, you just think about you divide the top row by the bottom row. And on the top row, you divide A over A plus B, and the outcome of that is divided by C over C plus D. So you do the calculation in 2 steps. Don't mix it up. First, calculate the first risk of the exposed, and then calculate the risk in the non-exposed and divide the two numbers by each other. And maybe an example will make it more clear. So in this example, study was conducted to investigate the association between smoking and lung cancer After following 20 smokers for 10 years, 5 of them developed lung cancer, and one of another 20 non-smokers developed lung cancer. What is the relative risk? This is the way you will get the question, and what you need is to focus and fill in the 2 by 2 table. So the first information that we have here, that the total number of smokers is 20. So we go ahead and put 20 in the total cell, highlighted here in yellow. And the question said 5 of them developed lung cancer. That fill in cell A, which is smoker, and at the same time they got lung cancer. So that's 5. And by simple subtraction, we can determine that we have 15 in cell B, which is smokers, but they don't have lung cancer. The same way, we fill the non-smoker row, and the question says we have 20 non-smokers highlighted in blue. We fill that in the total column of C plus D. And the question says one of the non-smokers got the lung cancer. That fill in cell C, which is non-smoker, but still they got the lung cancer. And by simple subtraction, 20 minus 1 is 19. That fill in cell D. And after you ensure that your calculation is correct and you fill the numbers correctly, the math is easy. Now let's do the math. Let's do the calculation. We will start with the risk in the exposed group. So I kept here in the 2 by 2 table only the smokers, only the exposed row to make it easy to follow. So as we said, we divide A by A plus B, which is 5 divided by 20, which is 0.25. This is the risk in the exposed group. The second step is we calculate the risk in the non-exposed group the same way, exactly the same way, from the 2 by 2 table. In the non-smokers row, we divide C by C plus D, which is 1 divided by 20, which is 0.05. And the third step is to divide the two risks by each other. So the relative risk is 0.25 divided by 0.05, which is 5. So the relative risk in this example is 5. And remember, this is typically used in cohort studies. And the second step after the calculation is the interpretation. So to interpret a relative risk, we need to remember 3 rules. Relative risk of 1 means no association between exposure and the disease. In other words, the two numbers of the risks in exposed and non-exposed are equal. And when you divide two equal numbers by each other, the product is 1. So relative risk of 1 means there is no difference in the risks between the exposed and unexposed. And a relative risk of more than 1 means the exposure is associated with increased risk of the disease occurrence. And a relative risk of less than 1 means the exposure is associated with decreased disease occurrence. Remember, there is no causality here, it's just association. And in our example, we have a relative risk of 5, which means the smokers have 5 times greater risk of developing cancer. So they are 5 times greater in risk to get cancer more than an exposed group. I hope that's clear enough. And now let's move to another risk measure, which is the attributable risk. And the attributable risk is measuring the proportion of the disease incidence that can be attributed to a specific exposure. In other words, quantifying the excess risk of disease in an exposed group compared to an unexposed group. And the word attributable means associated or related to. So we want to know how much of that disease is associated to a specific exposure by comparing the two groups, right? So the difference in risk between exposed and non-exposed means we subtract the two risks. So we start the same way we did in the relative risk. We calculate the risk in the exposed group, and we calculate the risk in the non-exposed group, and we just subtract them from each other. So the 2 by 2 table for our previous example is the same, and just the equation is different. So attributable risk equals 1, calculate the exposure, which is A, divided by A plus B, and then minus the risk in the non-exposed group, which is C divided by C plus D. So in this example, the attributable risk will be 0.25, which we already calculated earlier, minus 0.05, which is the risk in the non-exposed group. And the product of this subtraction is 0.2. You can keep it like this, 0.2, or you can say it's 20%, because the equivalent of 0.2 is 20%. And the interpretation of the attributable risk is when we say we have attributable risk of 20, that means 20% of lung cancer cases in smokers can be attributed to smoking. Please just focus here and see how you interpret it, because it's the way you put the words. It's 20% of lung cancer cases in smokers, because we're talking here in the exposed, can be attributed to smoking. So I hope this is clear enough. And I believe that's all for today. We'll continue in measuring other risks and providing example for that in our coming presentations. So stay tuned. And thank you so much.